Okay, so we would like to compute the limit as x tends to 1 of x cubed minus 1 over x to the fourth minus 1. We have already mentioned in class that if we want to compute such a limit of a rational function, in other words, the first thing that we should try to do is just plug in the specific number that we're approaching, in this case 1. And if we get a number that does make sense, that is going to be the limit. But here, if we plug in x equals 1, we actually get 0 over 0. And in this case, there is a very standard thing that we're doing, which is to apply synthetic division, factor out x minus 1, do a cancellation, and then be able to plug in, meaning be able to do what we couldn't do in the very beginning. So let's actually try to execute that. So let's do a synthetic division. And for x cubed minus 1, we will have 1, 0 second degree, 0 first degree, and negative 1. We put the 1 here, and we get 1, 1, 1, 1, 1, 1, 0. So here are our three numbers. This implies that x cubed minus 1 is the same thing as x minus 1 times x squared plus x plus 1. And for the other one, it's pretty much very similar. So this time we will have 3 zeros. And 1. And a very similar situation. Oops, sorry, this negative 1. 1, 0. So this will give us that x to the fourth minus 1 is x minus 1 times x cubed plus x squared plus x plus 1. So if we go back now to our limit with these two synthetic divisions, then we will have that the limit as x tends to 1 of x cubed minus 1 over x to the fourth minus 1 is going to be equal to the limit as x tends to 1 of x minus 1 times x squared plus x plus 1 over x minus 1 times x cubed plus x squared plus x plus 1. So these two things cancel each other, and we get the limit as x tends to 1 of x squared plus x plus 1 over x cubed plus x squared plus x plus 1. And now there's a significant difference with the initial limit, and I would like to circle the two so that this difference can be amply observed. So take a look at these two limits. If you try to plug in x equals 1 on the first limit, you would get 0 over 0. That doesn't make much sense. But for the second one, after the nice simplification, now we get a very pleasant number, 3/4. And that's the limit. And also notice how we carried the notation limit with us all the way till we were able to plug in and find the limit. And that's all for today. Thanks for watching.